Hello everyone, this is Scott Hinson, otherwise known as SpeakerScott. Welcome back. Sorry for the glow. It's a little hot in my asylum of sanity here. So remember that SAE amplifier that we were looking at before? Well, I've done a little bit more debugging on it. So one of the things that really concerned me with the amplifier, and was the thing that gave me the most hesitation, was the fact that that fuse had been replaced by a piece of wire. The reason is this. A lot of times the engineers have done a really good job sizing the fusing and overcurrent protection so that if something bad happens inside, the failure is not catastrophic to the hardware. The real reason for the fuse is so that the thing doesn't catch on fire, but in many cases the engineers will use the opportunity to save as much as they can of the internals. Okay? I've walked away from Macintosh amplifiers that somebody has replaced the mains fuse, because that's one of the few things that will kill one of the Macintosh autoformers. All right. It's supposed to be a 5 amp fuse. The guy had a 20 amp fuse in there and said it kept popping, and I just turned around and left because I can't take the chance that that autoformer was bad. So in the case of this SAE amplifier, I got it so cheap that I'm not sure I care if the transformer is bad. I have other transformers from other amplifiers that would probably work, but I'm hoping that it's not. So here's what I did to check. I disconnected the amplifier from the transformer, and I hooked the whole thing up to my autoformer and dim bulb tester. Okay, and that looks like this. And just so you know, here's your electrical safety violation of the day. Okay, there's the transformer, the autoformer. I can ramp up voltage slowly. I run the whole thing through this light bulb, so if there's a dead short circuit, it's limited to the current that would flow through that light bulb. All right, this can very often save the transformer, the output devices, and even some of the larger drive stage devices. Small signal devices will typically, if there's some sort of issue, if that thing lights up bright, they're dead anyway, but it saves you a lot of time and effort. This helps you bring it up slowly. This limits the current. This does not limit the current. All right, a lot of people get that wrong. So what I was worried about was if the transformer was destroyed because somebody had replaced that fuse. So what I did is I disconnected the transformer from everything else. Okay, so I'm measuring just the transformer. So I've got the low voltage VU meter windings here safed up. I've got, you know, the oh so perfect duct tape. Again, another electrical safety violation of the day. I've got some man killers here, some alligator clips to hook up to the transformer windings, and I'm measuring the voltage. I should see, for an amplifier of this size, right now I'm seeing about 67 volts RMS on the secondaries of that transformer, and for an amplifier at 50 watts a channel, that's about right. 33 volts RMS per voltage rail. That's looking pretty good. So my biggest fear about this thing, that transformer was cooked, it's not the case. The transformer's looking good, so it looks like at worst case we'll be in for some transistor and capacitor replacements. Pretty cheap. Talk to you later. Bye.